Hello, so in this video I'm going to talk about lasers. So at their most basic, lasers are sources of light, but they're sources of light with some very special properties, which make them useful for a wide variety of applications. And in this video what I want to do is talk about, firstly, what those properties are, and why it makes them so useful for such a variety of applications, from laser eye surgery to industrial machining to DVD players. And then I'll talk a little bit about the key components that all lasers have in order to work. And hopefully that should give you a nice introduction to what exactly lasers are. So nowadays we use laser just as a word, but it actually began as an acronym. And what it stood for was light amplification by stimulated emission of radiation. And that kind of makes sense. We know that we're going to have emission of radiation because it's a light source. But the thing that really differentiates a laser from other light sources is this idea of amplification. And I'll talk more at the end exactly how this amplification occurs. But at a very sort of simple way of thinking about it is that in many cases light is absorbed. If you shine light through the atmosphere or even a glass of Coke, the intensity of light coming out is lower than the intensity of light going in. But within a laser, we use some kind of material that can amplify the photons. It can increase the intensity of light coming out compared to the light going in. But again, I'll talk about that more towards the end of this video. So what then are some of these properties that make lasers different to other light sources? So one, we have directionality. The light of a laser is emitted in a single direction. So in contrast to something like an incandescent light bulb, which is going to be emitting light in all directions, our laser beam emits its light in just one direction. So in the case of a light bulb, you want it to emit in all directions, so you can just stick it in your ceiling and it lights up the whole room. But that does have disadvantages. It means you're not concentrating the energy. It means quite a lot of energy is being wasted by going up into the ceiling or places that you don't want to illuminate. And really, these things aren't problems for a laser. You get this nice directional beam, as you've probably seen in a laser pointer. And this directionality means that the beam can shine over long distances. And more than that, it also can have a very high power because you've got so much energy in a small area. And that is the reason it can be used in things like laser eye surgery or in industrial applications to cut or pattern metals, for example. A second important property of lasers is that they are monochromatic. That is to say that the light is emitted of a very distinct wavelength. It has a very single colour. So you don't just have a sort of a red or a blue or a green laser. The light emitted is a very specific shade of red or blue or green, for example. In contrast again to an incandescent light bulb, which seems to us to be white because it's emitting all wavelengths of light. Now, this monochromaticity has a lot of uses, from things like spectroscopy to actually DVD players. So all DVD players have a red laser in them, and a red laser with a very specific wavelength. And this actually means that you can play any DVD on any DVD player, because the laser is attuned to the spacing of the grooves that have been cut into a DVD. So the way a DVD player works is that a DVD has grooves etched into it, and the laser interacts with these grooves. And the way it interacts depends on the wavelength of light. And by using a laser, and exactly the same laser in all different DVD players, it means you can get reproducibility. You know that what you see on a DVD will be the same as what your friend will see on the same DVD. And the third property, which I'm only going to touch on very briefly, is coherence. And this really is a measure of how similar the light is at different points in time and space. But I'm really not going to dwell on that because that really would need several videos in its own right. But what it does mean is that you can use a laser in applications, for example, holography, which really require coherent light. So then we've said that a laser is a source of light, and it's a source of light which emits light in a single direction of a single colour and with coherent properties. And now what I'd like to do is talk a little bit about what you use to make a laser, the real key components. So lasers come in a wide variety of different forms, made of a wide variety of different materials. And they can be different sizes, from things on the order of with a size of the order of a human hair to huge devices which can fill a room. And they can be made from gases or liquids or even liquid crystals, for example. But at their heart, most of them have three core components. The first of these is what's called a gain material. So this is something which can emit photons. This could be a fluorescent dye, it could be a gas like carbon dioxide. And it will emit photons. And depending on the material, it will emit photons with different energies, which will give the light different wavelengths. So this is how you control the monochromaticity. This is why a laser is monochromatic, because the gain material will just define exactly what wavelengths are being emitted. Now, in order to get emission, we need to put some energy into the system. And this is done using something called a pump source. Now, this could be electricity, which is what you'll have in something like a CD player. It could be a flash lamp, which is basically something which produces a burst of very intense light. Or it could be another laser. And this essentially gives the gain material the energy that it can start emitting. But in order to get the amplification, what we want is some kind of feedback mechanism. And this feedback mechanism is most often, although not always, provided by mirrors. And mirrors are the easiest way to visualize it, I think, so that's what I will draw on here. So basically you have a mirror either side of your gain material. Sorry, they should look the same. And then you pump your gain material, which causes it to begin to emit. And then because of the mirrors, the laser light bounces backwards and forwards between the two mirrors. And as it does so, it stimulates more and more emission from the gain material, and you're building up and building up the light. You're getting amplification. And now, because our mirrors have a reflectivity of less than 100%, that is to say, not all of the light will be reflected, some of it will just pass straight through the mirrors, we then get a beam of light passing through the mirrors. And this is our laser beam. So they're the three core components that we have to our laser. We have a gain material to emit, a pump source to excite emission, and then some kind of feedback mechanism, most often provided by mirrors. And actually, this helps explain where we get the different properties of a laser from. We get directionality because all the light is being emitted perpendicular to the mirrors. We got monochromaticity because the photons that are being emitted are defined by the energy levels within our gain material, defined by the photons that the gain material will emit. And then the coherence comes about due to the properties of the what's called the cavity, so this area between the mirrors. But again, I won't dwell on that. So hopefully this video has given you an introduction to lasers. So given you the idea that they are simply sources of light, but they're sources of light which emit light in a single direction, which gives them the ability to travel over long distances and to have high power. They are monochromatic, they have a very distinct colour, and they're also coherent. And that at the core of all lasers is some kind of gain material to emit photons, some kind of pump source to excite it to emit photons, and then some kind of feedback mechanism, most often provided by mirrors. Thank you.